All right, so probability, distribution, and frequency tables. It all just gives us a sense of where the data is at, what's the spread, what's the chance of certain things happening when you ask a question that has multiple answers. Think of like a survey question. So to get the vocabulary done, we can reference back to this. A frequency table is just a data display or data chart that shows how often an item appears in a category. Think about when you're asking a survey. Just like this one down here, where we're asking a survey of favorite board game with 5 options. This is a frequency table right here because it just shows how many people voted for or fall into a certain category. Now, the relative frequency is a single ratio, so it's going to be a part of a whole, because the whole in this case is going to be the total frequency, which in this example is 30 people. It's a ratio or a fraction of the category. So like the total number in that category to the total frequency, which you can think of as like the total number of votes. And our probability distribution gives the probability of every single one of those outcomes. It just does a lot of calculations so we can see how likely each outcome was. So the key formula here is when it says relative frequency, you're going to select the frequency of some desired outcome over the total. So when I look here and I want to see how many people chose chess, what's the relative frequency of choosing chess? Well, that's just going to be the frequency of the chess category over the total frequency. So that would just be the 6 over the 30, which is 1/5. So a 20% chance that someone you pick out of this group is going to favorite chess. So for Catan, it would be 8 out of 30, and for Battleship, it would be 2 out of 30. And what's the sum of all 5 relative frequencies? Well, if you add up 6 out of 30, 11 out of 30, 8 out of 30, 2 out of 30, and 3 out of 30, if you add up all those numerators, you get 30. So it's 30 over 30, which is 100%, or 1, or 1 over 1. So all the probabilities together in a probability distribution need to add to 1. You have to have 100% of your audience captured in your distribution. Okay, so here's an experiment where a student was flipping the coin 3 times and recording the exact heads and tails that they got. And they did this 50 times. So this is the total frequency. Using the results in the table, what is the probability that exactly 2 heads occur in the next 3 tosses? So if she were to go for that 51st trial, what do you think that should get? So if we need exactly 2 heads, we're either here, here, or here. So the frequency of exactly 2 heads over the total would equal 7 plus 6 plus 2 over 50, because this is the total number of all of the successes that are happening here, all of them in that category. So ultimately we get 3 out of 10, which is a 30% chance that will happen. Okay? And in class we did a survey of the whole class of how many cats everyone had. So let's say if we did 0, 1, 2, 3, 4, let's say that 5 people had no cats, 10 had a 1, 5 had 2, 0 had 3, and 2 had 4 cats. That would be a frequency table. What's the probability that a randomly selected student has exactly 1 cat? Well, that would be just this category. So 10 out of 22, because that's the total frequency, the number of people in the class who were in the survey. Okay? And you could write that as 5 out of 11. So 3 more examples, and that'll be it. So some data from last year, out of the 47,106 undergrads, about 10,000 chose majors in the top 5. And those are listed there. What is the probability distribution of that? Okay, so the probability distribution starts with frequency. So how many people were finance majors? How many people were biology majors? And we fill in all the rest. And the probability is simply just going to be that frequency, the number of finance majors, divided by the total set. So the total number of undergrads. And by the way, we have to kind of assume here that there's no double majors. But that's obviously a lie. There are plenty of double majors. So kind of a flaw in our study here. But we would just take that and we would divide that. And I got 6.41%. And we would do the same with biology and divide. And we expect this number to be a little smaller, and it is. Okay? And we would just fill in the rest of the table just like that. So we see that the chance of someone being, like if you were to pull someone off campus, an undergrad, and ask them, what's your major? There's a 78.5% chance that it won't be one of these top 5. But there's almost a 7% chance that they're a finance major. And if you were polling next to the business building, I'm sure that number would go up, right? That's what's called conditional probability, which we'll look at later. But yeah, that's a probability distribution. It's got the name of the category, the frequency, and the probability. Okay? So last year, I guess 2 years ago, the Reds baseball team are hitting between 0 and 6 home runs every game. And it says complete the probability distribution for the number of home runs hit per game. And using the distribution, what's the probability that the Reds will hit more than 4 home runs in their next game? Okay. So how we read this is we would say, okay, there were 46 games where the Reds hit 1 home run. And there were 4 games where the Reds hit 5 home runs. So to complete the distribution, we simply just have to put all of these over the total. And then the question was, what's the probability that the Reds will hit more than 4 home runs in the next game using the distribution? So that would be the frequency of more than 4 home runs over the total frequency. And more than 4 is this category over here. So there were only 5 times where that happened. Okay? So that would be your probability that might happen. Now, is that guaranteed that, no, it's based on your data. It's experimental. But because, we really don't know what's going to happen in the next game. It could be rained out and they may not even play, right? But, yeah. So I also made up this is also a class survey one. If you had to fill out the entire probability distribution, for each one of these, you'd say, okay, I surveyed 7 of them have 1 sibling. And this was a class of 20 because I can add this up and this equals 20. So all these probabilities are the relative frequencies. So 7 out of 20, 6 out of 20. Okay. And then finally, what's the probability that a randomly selected student is not an only child? Well, that would be anyone that falls in this category. So we would do 7 plus 6 plus 3 plus 0 plus 1 over 20, which is 17 over 20, which is about 85%. 85% chance you just randomly pick someone and they're not an only child. But there's a 15% chance